Now that we are more familiar with the quantile regression model, we can proceed to applying the quantile regression model. The quantile regression model corresponding to the linear regression model equation above for the pth quantile is yi is equal to beta null at the pth quantile plus beta 1 at the pth quantile xi1 plus plus beta k at the pth quantile xik plus epsilon I at the pth quantile. Considering data points x sub I, y sub I, for I equals 1, 2, n hanggang sa kung ilan man yung observations mo, where p, which is between 0 and 1, is the pth quantile, therefore indicating the proportion of the population or sample having values below the quantile p. Next, the notation for the pth conditional quantile model, which is the model for a specific quantile, on the other hand, is as follows. So q at the pth quantile of p of yi is equal to beta null at the pth quantile plus beta 1 at the pth quantile xi1 plus plus beta k at the pth quantile xik. So, pinasok lang natin yung equation kanina into a quantile function. And if you notice, nawala yung epsilon I at the pth quantile. So what happened here was na since pinasok natin yung left side into a quantile function, pinasok din natin yung right side. However, itong mga beta null at the pth quantile, itong mga to, these are just constants. So, constants din yung labas nila. However, yung q at the pth quantile of epsilon I, i-assume natin na 0 siya at the pth quantile, kaya siya nawala. Next, we can talk about determining the beta coefficients. Unlike the OLS, which aims to minimize the mean square error, quantile regression minimizes the weighted sum of absolute distance of the estimated points from the observed points without squaring. So if you recall, in OLS, yung ginagawa natin is kinukuha natin si observed minus predicted, and then square natin yun, and then minimize natin yung sum, which is, so minimize natin yung SSR. In quantile regression, on the other hand, what we do is we just get the absolute value of the observed minus predicted, and then yung sum nun minimize natin. Okay? However, hindi lang siya basta-bastang sum. Okay? It assigns asymmetric weights to the deviations depending on their positions relative to the fitted line. Okay? The weights are 1 minus p for points below the fitted line and p for points above the fitted line. So ito yung asymmetric weights niya. These weights lead to p% of the data points being negative residuals and 1 minus p% of the data points being positive residuals. So for example, if we were to consider the quantile p equals 0.10, then errors below the line are given a weight of 1 minus 0.10 is equal to 0.9, while errors above the line are given a weight of 0.10. As a result, 10% of the observations have negative residuals, while 90% have positive residuals. So, clarification lang on what negative residuals are. These are just yung points that are below the fitted line. So, negative residuals is when you are under-predicting. So, to provide a bit of background, consider the case of finding Q, the value of the pth quantile of some univariate sample y, which minimized the sum of the weighted y1, y2, yn distances from the sample points. This is given by the minimization of the following. So, ito yung distance function to minimize. And kung nagtataka kayo kung saan to galing, this is derived from minimizing the value of the expected value of the absolute value of y minus q extended to the pth quantile. So, ito kasing expected value of the absolute value of y minus q can be interpreted as a minimization problem. And then, pag kinuha mo, makikita mo na yung minimum will be found at the median. And then, in-extend yun to the pth quantile, and then ito yung makukuha niya. Now, hindi ko na ibibigay yung derivation nito, pero mayroon sa reference yung how and Nyman, makikita yun doon kung paano siya dinerive. And for now, tanggapin muna natin na ito yung distance function for this case, and we proceed and note that in quantile regression, we're minimizing the following. So, absolute value of yi minus etong buong to is just yi hat. So, it's a sum of the absolute value of observed minus predicted. So, if you notice, yung form nito is similar to this so that we can extend the previous formula so that the function to minimize can be expressed as etong distance function nito. Now, if you notice, meron na tayong p and then 1 minus p. So, dyan nanggagaling yung weights na ito. Itong 1 minus p for points below the fitted line and p for points above the fitted line. So, 1 minus p for when yi is less than yi hat. Okay? And then, yi is greater than or equal to yi hat, yung weight niya is p. To minimize the function, however, we need to apply linear programming methods or algorithms. Some methods are as follows: the simplex method, interior point method with pre-processing, and exterior point algorithms such as the steepest descent method. Next, we can talk about interpreting parameter estimates. Parameter estimates in the quantile regression model can be interpreted similar to the interpretation of parameter estimates in OLS. However, one key difference is that they can only be interpreted at the specified quantile. Quantile regression models can have different conditions. That is, a quantile regression model at a different quantile leads to different conditions and thus a different model. Therefore, an interpretation of parameter estimates of the QRM can be as follows. Based on the fitted quantile regression models, at the pth quantile, so ito yung main difference, an infinitesimal unit increase, say a 1 unit increase in the independent variable x will lead to an increase or decrease in the dependent variable y by beta units ceteris paribus. Outside of interpreting at a specific conditional quantile, parameter estimates at different quantiles can also be compared to see whether the effect of the independent variable x increases or decreases as the quantile increases or decreases. So, bukod sa isang advantage ng quantile regression na natitignan natin kung ano yung itsura ng model at different quantiles, another thing that might be of interest to us is kung paano nag-iiba yung effect ng x on y as we go through the different quantiles. Next, we check whether the model at the quantile p is significantly different from 0, as well as whether the model at the quantile p is significantly different from the OLS model of the data. The latter is important because it helps us determine whether a quantile regression model is necessary for the given quantile. So, yung isa pang difference is na chine-check din natin kung significantly different yung quantile regression estimate natin sa coefficient ng kapag gumamit tayo ng OLS model. So, ginagawa natin yun para ma-check natin kung may point ba na gumawa ng quantile regression model instead of an OLS model for the given quantile. Now, to illustrate all these points, suppose we have data from the Medical Expenditure Panel Survey, so MEPS Economic Economy. The dependent variable is the total medical expenditures in dollars, and then the independent variables are itong lahat ng to. Now, tignan natin yung total number of chronic conditions and yung age na variables. So, ito ay yung graphs ng regression coefficients across the different quantiles. Yung black with gray ay yung coefficients and confidence intervals ng quantile regression model. And then, yung red ay yung sa OLS. And then, ito ay yung quantiles nila. So, meron tayong dalawang key takeaway points. First is na makikita natin na nag-iiba-iba nga yung itsura ng model across the different quantiles using a quantile regression model. So, at quantile equals 0.2, pag i-compare natin siya with at quantile at 0.8, so iba yung itsura nila. Unlike in the OLS na the same lang siya throughout. Kasi hindi naman dependent sa quantile yung OLS. So, second na ma-take away natin is na minsan nag-overlap yung OLS and yung quantile regression model at some of the quantiles. So, around, let's say, 0.7, 0.71. So, around here, ito yung point at which hindi significantly different yung OLS and yung quantile regression model. So, walang masyadong point na gumamit ng quantile regression model. Hindi masyadong different as an OLS model at this quantile. So, ganun din sa age. So, here, makikita natin sa age na mas madaming overlap. So, baka mas hindi meaningful na gumawa ng quantile regression model. Another thing is na makikita natin na iba-iba din yung shapes ng quantile regressions across the different quantiles for different variables. Next, we can discuss confidence intervals. So, confidence intervals and standard errors play a crucial role in the interpretation of the estimates in a quantile regression model. So, the existence of a significant difference between the OLS coefficients and the quantile regression coefficients can be determined by looking at the confidence intervals of the quantile regression coefficients. Confidence intervals can also be used to determine if the quantile regression coefficient is significantly different from 0. So to determine this, check natin kung yung OLS coefficient is inside ba or outside yung confidence interval bounds ng quantile regression coefficient. So if the OLS coefficient is outside the CI bounds of the quantile regression coefficient, then there is evidence that the quantile regression coefficient and the OLS coefficient are significantly different. So the same way na if the quantile regression coefficient confidence interval does not contain 0, then there is evidence that the coefficient is significantly different from 0. So in determining the confidence intervals for the quantile regression model, yung closed-form solutions are again often practically impossible. Therefore, more flexible methods that make fewer assumptions are recommended, and these methods are achieved through methods such as statistical computing. Some methods that can be used are the bootstrap method, which is a modified Monte Carlo method, inversion of rank tests and other rank inference methods, normalized information distance, or the NID, and sparsity. Lastly, we talk about quantile regression in R. So to perform quantile regression in R, the quantreg package must first be installed and loaded. So ito yung mga code, pag-install and then pag-load. And then the function to perform quantile regression is as follows. So RQ, and then ito yung mga possible arguments. So a complete description of the arguments is provided in the course notes. Pero yung mga pinaka-important are yung X, which is your explanatory variables, Y, which is your response variable, and then tau, which is yung quantile at which ini-interpret, and then alpha, which is yung level of significance. In order to return the values of interest, similar to when using the function lm to create a linear model, the RQ model must be put in the function summary. Note, however, that the summary function changes its method depending on if the number of entries is less than 1,000 or not. This leads to different outputs depending on the method used. So, when your number of entries is less than 1,000, ginagamit niya is yung SE rank, and then when it's greater than or equal to 1,000, yung ginagamit niya is SE equals NID. So, magkakaiba yung ina-output nila. So, pag nilabas mo itong summary nitong SE rank, yung ipapakita niya is yung lower and upper bound, and then pag ginamit mo naman, pag yung ginamit niya naman is yung NID, yung ipapakita niya is standard errors with corresponding t-tests for each variable. So, kung ganun yung pwede mong gawin para ma-convert into confidence interval, pwede mong kunin yung value plus minus yung standard error times 1.96 for 5% level or of significance, and then i-adjust mo na lang accordingly para makuha yung confidence interval. So this will be further discussed in the examples. And then to make the summary function consistent, so para same yung makukuha mong confidence interval or same yung method na gagamitin sa pagkuha ng confidence interval mo, pwede mong iset yung method na gagamitin ng summary function. So the following code can be used: summary QR model or yung model mo, SE, and then yung rank or NID. Lastly, to compare whether multiple quantile regression models are significantly different from each other, the WALD test is used. To do the test, the following R code is run: ANOVA, quantile model 1, quantile model 2, quantile model 3, ... A significant F value from this test indicates that at least one pair of quantiles have models that are significantly different from each other. So, bakit natin gusto tong i-test? Tinetest natin to para malaman natin kung may significant difference naman between yung model at one quantile and yung model at another quantile. So, di ba na-mention natin kanina na interested tayo in checking kung nagbabago yung effect ni X on Y depending on yung quantile, and this is a more formal way to do that.